This is a video from my Calculus 1 Exam 2 review. The directions say to find the derivative, simplify your answer where appropriate. Let's take a look at number 18. On number 18, we have sine of xy is equal to x squared minus y. So we're going to differentiate both sides with respect to x. So the derivative of sine of xy with respect to x is equal to the derivative of x squared minus y with respect to x. Okay, let's take a look at the right-hand side. The derivative of x squared with respect to x is 2x. Then I'm going to go minus, and then the derivative of y with respect to x can be written as dy dx. That's the right side. On the left side, I'm going to write cosine of xy times the derivative of xy with respect to x. Okay? And so this is cosine of xy times. Now, by the product rule, I can say x times dy dx plus y times 1. And then on the other side, I'm going to keep 2x minus dy dx. So now I get to distribute the cosine of xy inside. And so I get cosine of xy times x dy dx plus, and then I write y times cosine of xy. That's the left side. On the right side, I have 2x minus dy dx. From here, I want to solve for dy dx. And then to do that, I need to move this dy dx term over to the left-hand side. So I get x cosine of xy times dy dx plus dy dx. And then on the right side, I need to move this y cosine of xy term over. And so I get 2x minus y times cosine of xy. Now we get to factor out a dy dx. And when I do that, I get x cosine of xy plus 1 is equal to 2x minus y cosine of xy. Now I get to divide both sides by x cosine of xy plus 1. And when I do that, I get dy dx is 2x minus y cosine of xy divided by x cosine of xy plus 1. That's a really good problem. That's problem number 18. Let's take a look at 19. Now, on 19, we have y squared plus natural log of y equals x times y squared. And we want to differentiate both sides with respect to x. So what we're doing in problems 18 and 19 is what's called implicit differentiation. So the derivative of y squared plus natural log of y with respect to x is equal to the derivative of x times y squared with respect to x. So if I look at y squared, the derivative of y squared with respect to x is 2y times dy dx plus the derivative of natural log of y with respect to x is 1 over y times dy dx. That's the left side. On the right side, I apply the product rule. So I write x times the derivative of y squared with respect to x, which is 2y times dy dx plus y squared multiplied by 1. So I get 2y dy dx plus 1 over y dy dx, and then I need to move this first term over to the left-hand side. So I go minus 2xy dy dx, and I'm going to set this equal to y squared. Now, to clear the fraction, what I'm going to do is multiply both sides by y, because I want you to watch what happens from there. So I get 2y squared dy dx plus, right? And that's this one. Then I do y times 1 over y, which is just 1. So I get dy dx, okay, minus. Then I'm going to take y times 2xy dy dx, which is 2xy squared dy dx. That's the left side. On the right side, we get y cubed. Okay? Factor out a dy dx. When I do that, I get 2y squared plus 1 minus 2xy squared inside the parentheses. And on the other side, we get y cubed. Solving for dy dx, I get dy dx is equal to y cubed divided by 2y squared plus 1 minus 2xy squared. And that's how you do problem 19. Let's take a look at 20. Suppose y equals tangent of x over 1 plus x squared. So this is a classic chain rule problem. And I'm going to let u equal x over 1 plus x squared. Then y is equal to tangent of u. So let's look at du dx. By the quotient rule, this is 1 plus x squared, right? That's the bottom, times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 2x, divided by 1 plus x squared raised to the second power. If I were to simplify that a little bit, I claim I'm going to get 1 minus x squared divided by 1 plus x squared squared. Now, dy du is secant squared of u. Now we get to put it together. dy dx is dy du times du dx. But dy du is secant squared of u. Du dx is 1 minus x squared, that's the numerator, divided by 1 plus x squared squared. But remember that u is x over 1 plus x squared. Now we get to make our substitution. Dy dx is secant squared of x over 1 plus x squared, okay, times 1 minus x squared divided by 1 plus x squared squared. And that will conclude this video. Okay, thank you.